Alrighty. Hello everyone, welcome. Hope you're having a good week. Happy Valentine's Day. Just a couple of quick announcements before we hop into today's topic. First thing is that I screwed up assignment 3 a little bit. A couple people noticed and emailed me about this. The address that I gave down here to access the repositories was incorrect before. I forgot to put a little chunk of the URL in there, so it wasn't working because I didn't give you all the information. That's totally my fault. Sorry about that. It is correct now. I fixed it. So take a look at that if you've been having problems cloning the Git repositories. I promise they are there. They do work. Apologies to those who got stuck on this. I think that's the only real major announcement that I have. We're just kind of cruising along for another few weeks until we shift gears to the project around spring break. So I'm going to start grading assignment 2 today, but I am pretty busy this week still, so I probably will not get it finished today. And if you're still working on it, just yeah, keep chugging away. There's no reason to stop now, but definitely let me know if you get stuck or have any questions on any of the assignments, really. Does anybody have any questions about assignment 3 right now that I could address before we talk about today's topic? Alrighty. So today's another really fun one, at least in my opinion. I mean, I think a lot of these topics are really fun, but this one in particular, I think we're going to have a good time with today. We're going to talk about unit testing. So unit testing is something that I feel like most of you are probably at least somewhat familiar with, especially if you've taken other comp sci classes here at WashU. We introduce unit tests in 131. We don't do it until maybe about halfway through the semester. But then once we introduce unit tests in 131, that's how we do things from then on out. It's all unit tests for most studios assignments, and I know a lot of other classes do it that way as well. I run classes like that. However, I think one thing that kind of gets overlooked in a lot of those situations is where the heck do those unit tests come from? Somebody has to write them. Somebody has to make them. How do they do that? How do they make those choices? How do they decide what the test should be for? It's actually, I think, a more important part of the design process is writing the tests, or including the tests as perhaps the first thing that you think about instead of writing the actual code. So we're gonna talk about unit tests today, how they work, how to write them, but also I'm gonna encourage you to kind of maybe flip the script on what you think unit tests are like. We're not gonna write the code first and then write the test to match the code. We're actually gonna write the tests first and then write the code to match the tests. So it's gonna feel awkward, it's gonna feel weird, it's gonna feel very different from the way you approached programming problems in the past. But I think it's good to exercise your mind a little bit, stretch the way that you think about things, and hopefully I can at least try to convince you to as to why it might be a good idea to do such a thing, as to why it might be a valuable way to think about approaching our code and our projects. So today we're gonna start using Eclipse. We're gonna start using an IDE. I am assuming that all of you have Eclipse just from other classes because you take 131. If that's not true, which I hope that you all have Eclipse. Don't freak out. You can definitely, it's free. You can go download it and install it. If you want to use something that's not Eclipse to write your code, I don't necessarily have a problem with that, but I'm going to be using Eclipse, and I know how to use Eclipse really well, so that's probably what I'm going to stick with. But if you have another way that you use that you like to write code, you're not going to hear any arguments from me. I do think there are some advantages to using Eclipse for this purpose, and we're not going to stop using the command line either. In fact, later on today, I'm going to show you how Eclipse and the command line can interact with each other. So let's get started. We're actually going to, before we can do anything, we're going to make a new project. We have to, have a place to begin, have a place to start working on this code, and you can see I've got a bunch of stuff from just classes and other things on here. I want to make a new project for what we're going to be working on today in this class, and the goal that I have in mind for us is to make just like a simple like an ordering system like you see, at any of the dining hall stations where you click on what you want, it tallies up the order, tells you how much money you owe, adds on taxes or anything like that if it needs to. We're just going to make a simple menu system, simple like a restaurant ordering system as a way to play around with some code and write some unit tests. So I'm going to make a new project. If you have Eclipse up and running already, the way to make a new project is to right-click and then say New Java Project. I'm imagining this is probably the first time a lot of you have done this on your own. A lot of the times if you get something from us in a class, it's just given to you, right? We give you the project, it's got all the code and stuff in it that you need to get started, and then you just start off and running. But if you're trying to make up something from scratch, step one is to make a project. I'm going to call it, I'm going to put CSE237 out in front just so that I know it's for this class. And then I'm going to call it menu system because that's what we're going to be hopefully making. It's a menu system. I know that text is really small. I can't figure out how to make this text bigger, but I can make the code bigger at least. This stuff might look a little bit different than mine. It'll depend on what version of Java you have installed, which really for this purpose does not matter. If your version of Java is different than mine, then okay, that's not really a big deal. Not going to be a problem at all. I typically like to uncheck this box down here at the bottom. I don't know what it does, and I feel like it just gets in the way, so I usually uncheck it. I honestly have no idea what that does. But yeah, this is an empty project. What we're looking at in this empty project, the structure, this is Java. This is quite literally everything that Java provides to you. So strings, math, all that fun stuff. And then this SRC folder, that's where the source code is going to go. So any of the Java code that we wish to write, any of the classes that we wish to create is going to go in this folder. But actually, we need to do something else first. There's something that typically goes in these folders called a package. So you've probably actually seen this word before at the top of basically every Java file you've ever looked at, right? A package is just a folder. It's just a directory. It's just, I don't know why they call it that in Java, but that's what it is. It does have a little bit more significance than that. I'll show you that later on today when we get back into the command line. But for now, you can think of it very much as just a folder or a package. And I'm going to call this, I'll just call it menu because I can't think of anything better to call it. And at this point, we probably have something that looks like, what you have perhaps worked with in the past. Most students who have gone through 131 know that they can right-click on one of these and create a new class, which is what we need to actually start writing Java code. And I would like to do that as well. I would actually like to create a new class. I'm going to call it menu item. So the idea is that this is going to represent a single piece of food, right? A single thing that we can order off of the menu. Now, coming up in the next week or two, we're going to be talking about clean coding techniques. So I'm not going to get too deep into how to design classes and make classes and things like that today. But I do think that this is going to be what I would call a data class, or just a simple class that stores information and gives that information back when we ask for it. So it's going to be a very simple class. It's going to have some hasas, right, which are instance variables. So probably needs a name, and it probably needs a price as well, which we'll just use a double for. I'm sure there are other things that we could conceive of having on here if we wanted to add a description, right? A lot of times menus will have descriptions of the items. You could include that. If you wanted to add like traits about whether it's gluten-free or vegetarian, you could add that. That's all possible. But we're going to keep it simple today. We're going to focus on these two main things. And then I'm going to create a simple constructor for it that is going to look very similar to, very straightforward, very standard. We're not doing anything too terribly crazy so far. right? And I'm actually almost done with this class, believe it or not. Almost done with this class. The last thing that I want to do is generate some getters for these. So I'm going to do that by, hopefully you've seen this trick before, but if not, this is a good one to know. I'm going to right click somewhere in the file and I'm going to go to, where is it, source, generate getters and setters. I actually just want getters, I believe. I don't think I need setters, so I'm just going to make sure to select the getters on this menu. If you'd rather type it out, I mean, getters are very simple, very straightforward. But we're going to use the IDE to help us out here. And then poof, there we go. There's my getters. I went through this rather quickly because I actually haven't shown you anything. I'm assuming that you picked this up. We cover all this stuff in 131. I know maybe it's been a little while for some of you, but it hopefully shouldn't be like brand new, at least. We're getting to the brand new stuff. Just kind of setting up some hurdles for us to consider first. Or setting some groundwork for us. Does anybody have any questions about what I've done so far? I'm actually done with this class. Our next task is to write some unit tests, which is what our main goal is for today. So I want to start writing some unit tests, but I'm actually not going to write tests for this class. I would argue that there's nothing to write tests for if the class just contains getters and setters, and that's all. There's nothing else in it. Unit tests aren't necessary. I would like to write unit tests for the class that doesn't exist yet. Right? We're going to create it later, which is going to be the order class. So I'm going to make the class right now, just so that we have something that we can work on over time. An order is going to consist of many menu items, right? So I'm going to select, cheeseburger, fries, and soda. So that order would have 3 things on it, right? What's the purpose of this class? I think that this class should be able to essentially function as our receipt in a way, right? It's going to be able to compute the total cost of the entire order. It's going to be able to compute taxes on the order, if that's necessary, right? Tell us a list of things that we have gotten. Give us a list of things that we're ordering. Those are things that can be tested, and those are things that should be tested. Things that we want to ensure are working properly. It's more complicated code than simply getting or setting a value. We're computing some arithmetic here. We want to make sure we get that right. So in order to make that happen, we're going to write some unit tests. I'm actually going to come up and put them in a different package. So I right-clicked on the source folder here. I'm going to make a new package called test. This is always a good idea, to keep the test separate from the actual code. This is generally considered good structure. Again, think of these just as folders, right? This is where the actual code goes. This is where my unit tests go. Separate folders. Keep things organized. Our next step is going to be to right-click on the test package down here. And I'm actually not going to create a class this time. I'm going to come down here and create a JUnit test case. I'm going to give it a name. We'll call it order test because that's what we're going to be testing. Up here at the top, make sure you've got the JUnit Jupyter test selected. These are older versions. I'm definitely going to be using this style of unit test, which does make a difference. These older versions will look a lot different than that. So make sure that you've got the the newest version selected up top. Got a name here. This window is saying that in order to use the unit test, you have to have the unit test library as part of the project. And it's offering to add that for us so that we don't have to do it. We don't have to dig into the menus and do that ourselves. That's a nice thing. We want that. So I'm going to go ahead and click OK. And here we go. This is our very basic test setup. And it's even given us a blank test which we can use, which is really just a method. A unit test is just a method. But unlike the methods you've seen before, it's going to follow a very specific structure, a very specific format. We're going to do kind of the same three things for every unit test, or attempt to do the same three things for every unit test. So the first thing to consider is, what are we actually testing? What are we actually testing for? What is the piece of behavior that we want this test to be testing for? So I talked earlier about how we're going to be able to have to be able to compute the sum of the orders based on the items, right? Or maybe we should take it even simpler than that. I think there needs to be a way probably for the order to tell us how many items there are in the order, just the quantity. You picked three things, right? Let's keep it even simpler than that. We'll get to the computing the sum part later. So I'm actually going to rename this method based on the behavior that I'm going to be implementing. So what I'm trying to implement here is, the order count, or the item count, I guess would be a better way of saying it. Oh yeah, I actually neglected to talk about this little guy right here. Does anybody know what these are called? There's a little @ sign out in front. That indicates that this is called an annotation. That's the term for that in Java. Annotations are just little clues to the compiler, basically, about what this code should be used for. So this annotation is saying that this is not a regular method. This is intended to use unit test. And every single unit test that we write is actually going to have that @test symbol come before it, as you will see. Okay. So we want to test whether our order can properly keep track of the number of items that have been ordered. Think about what that means. Think about what all needs to happen in order for us to test this. We have to be able to create menu items. We know we can do that. We have the menu item class already written. It's just a simple data class. But we also need to have a way to create orders. And we haven't talked about that yet. I've not talked about what instance variables are in the order class. I'm not talking about what methods are in the order class. I'm not talking about any of that stuff. That's actually kind of the point. We should be using the unit test to help us make those decisions now. How do I want these objects to work? I'm going to write down how I want them to work in the unit tests. And then I will write the code in the class to make them pass the test, meaning that they behave in the way that I expect. So I'm actually writing down the expected behavior. This is how I would want to use the code in an actual application, right? That's what the test is trying to simulate. So we've got 3 steps. First, we need to set up objects. So step 1 is always going to be set up objects. Sometimes this will be simple. Sometimes this will be tricky. We actually have kind of a tricky one for starters, I would say. We can create menu items simply by calling the constructor. Did I put the name first? Yeah, I think I put the name first and the price second. Sure. It's called menu item. Let me scooch this over. So this is how we would create a menu item based on the constructor that we wrote over here, right? The name and the price. It's mad because we need to import it. So if we allow Eclipse to import this, oh wow, I don't know what that is, but this is the one that we want. The one from the menu package is the one that we want, not the top one, but for me it was the second from the bottom. This is what the import should look like. You want to double check. So we have a menu item. We can use this to kind of test our order, right? But we also need an order. And this is where things start to get a little bit more abstract. I'm going to call the order constructor, even though it does not exist yet. It might seem like a silly thing to do, but this is test-driven development. It says, write the test first. Write the code as you think that it should work. Right? Call the constructor, and as you call the constructor, think about how it should work. So, okay. Here's an order. I'm going to call O, and I'll just say new order, and I have to decide right now, should there be any input parameters here or not? I'm making this decision right now. I'm using the test to help me design how I think this class should work. And then once I've made that decision, I'll go make it work that way. So there's two ways that I can think of this going, and both could be valid choices as to how we handle this, but one is to just leave it blank. Just say, nah, I don't need any input parameters. That's a pretty simple way of doing things. The other way of thinking about this is that it's always possible to come back and add things later if we need to, right? I haven't justified the need for an order to contain anything. What we're really asking is, what instance variables do we think the order should contain? So if I'm keeping track of multiple things, that tells me it's probably going to have a collection of some sorts, an array, or maybe a list would probably be a good choice for this purpose. Do I need to accept a list as an input parameter to the constructor to set that instance variable? Not necessarily. Not necessarily. We actually oftentimes we'll just create an empty list within the constructor instead. But the other option is to, okay, maybe accept a list of menu items here as part of the constructor. And I don't think that's necessarily a bad choice. It's just a different choice that has different implications, right? It has different implications. I'm going to follow this path and see where it leads. But if we have time, we can go back and maybe examine what it might look like if we do something else. I need a way to get menu items into the order. I need a way to say that I wish fries to be part of my order, right? That's a method. That's a behavior. We've identified that there is a need for orders to accept menu items and add them to the order. That's a verb. Adding something to an order, that's an action. That's a behavior. That's a verb. We've identified the need for a method, so I might call it add item. And we have the same question that we had with the constructor, actually. What parameters do we think that an add item method would take in? I think it would probably take in one parameter, which would be a menu item. And we have one from our unit test, right? We have one. So we can say that. Again, this method does not exist yet. So it probably feels a little weird writing code calling a method that does not yet exist. But we're actually designing the object by making these choices. I think that's the test-driven development way of thinking, is saying that I'm going to write how I wish to use the object first. And if I understand how I want to use the object, then it should be easy for me to make it work. Which is what we're going to do next. Once we're done with this unit test, we still have a little bit more to go. Now that we've added an item to the object, I think we're actually done with step one. Step two is to call the method being tested. this unit test since this is the first one that we've really looked at and dissected. But every unit test should be thought of as applying to a method. So before you start writing a unit test, there should be a method in your mind that you are using this unit test to test. Right? This unit test is for, actually the method that I have in mind for writing this unit test for is something like get number of items, right? Okay. So let's go ahead and call that method. I'm going to store it in a variable. And that actually is the end of step 2. Step 3 is to use an assertion or multiple assertions to verify results. So in this case, what did I do? I created an order. I added one item to that order. I said, hey, tell me how many items you have. So I'm going to use an assertion to say, this value right here should be 1. And if it's not 1, something went wrong. Because I made the order, I added an item to it, there should be 1 item on that order. Right? So assertions are really just methods, and they come in many different flavors. We can say assert true, we can say assert false, we can say assert equals, or is it equal? I can't remember if the S is on there or not. I'm sure Eclipse will be happy. Well, is it telling me right now? Assert equals. I'm sure Eclipse will be happy to tell me if I get it wrong. I think assert equal will work. No? Am I spelling it wrong? Okay, so assert true works, which is good enough for our purpose. We do need to import it, so go ahead and select the import that Eclipse suggests for you. And what I wish to assert to be true is that number should be 1. This is a complete unit test. This is what I would call a complete unit test. It has 3 parts. We set up our objects, get them ready to be tested. We call the method that we are testing. And then we use an assertion to verify that the results that we got are correct. This test is not going to work though, right? It's going to fail. Because, again, we don't have an order class. I mean, we have the class, and we haven't actually put any code in it yet. So this is the next step of test-driven design, which is, okay, we've written a unit test that fails. That's step 1. Write a unit test that fails. And then step 2 is go write the code that makes the test pass. So that's what we're going to do now. We have to go lay the groundwork for this order class until we make this test pass. So in order to do that, we can come in here to our order class and start thinking about, we've actually already made the decisions. We made the decisions as we were writing the test. So if I look at the test, I can see that, okay, there's nothing in the constructor. There's no parameters, so that's very easy for me to write. There was still an instance variable. It needs to have I think we said maybe a list or something like that. So we can start to piece this together. It's going to be a list of menu items. Call it items. I'm able to do this very quickly because I know that there's no parameters here. So that means that I'm probably just going to initialize this to be an empty list to start out with. This is all stuff that I would have expected you to have seen in 131, which again I realize is a long time ago for some of you perhaps. I need to import this, and import this. There we go. Let's take a look at our unit test again. I see that there must be a method called add item that accepts a menu item in. I can kind of already envision in my head that it's just going to take that menu item and stick it on the list that we have, right? Take that menu item in and stick it on the list. We can do that. Oops, that's not the right class. Here we go. I can tell by the way that the method is called what the return type is even, right? I can tell that it's probably void because it's not storing anything in a variable. So using the test, we can actually make it actually makes it pretty straightforward to write the code. We've already made the hard decisions as we were writing the tests. I'm going to go ahead and use the add method to add that to the list. And then finally, we have a method called getNumberOfItems that looks like it does not have any parameters, but it does have a return value, right? The way that I've used it. That should be a pretty straightforward method to write as well. Oh, it's called items. And at this point, oh, I have to, what's the matter? Have to import the order class. That's what it's upset about. At this point, assuming that you've imported the order class, there's no more errors, right? There were errors before because this code didn't actually exist, that we were calling methods before they existed. But now that we've got our unit test, we were able to go and write the methods. They exist now, and hopefully, fingers crossed, this test will actually pass. I'm pretty sure you all know how to run unit tests, so we can right-click the file, run as unit tests, and then we got that green check mark that we all like to see. Got that green check mark. We're not done yet, though. We actually have more work to do. But does anybody have any questions so far? I know this probably all feels new. We're going to do it at least, we're going to go through this process, well, the 3 steps, as many times as we can today. So we'll go through it at least a few more times today. You guys have any questions right now? This feels new? A little different? So let's talk about what to do now. We actually, I would argue, have not done a sufficient job of testing. And so this is one of the more common critiques that you're going to hear from me on the project is not enough unit tests, not enough unit tests, not enough unit tests. Real professional grade unit testing tries to consider as many possible situations as it can. So let's think about not just the simple case of adding an item to an order, but what are some extreme cases? One such example of an extreme case is, what if I don't add anything to an order and it's still properly tell me the styles? I would consider that the smallest possible extreme test. What if I add the same thing to an order more than once? Can it handle that situation? Should it be able to handle that situation? Or do I not want to allow that behavior? It's kind of up to you as you're writing these tests to signify that, right? So there shouldn't just be one test for this method. There should be lots of them. So, I might say this is a simple test. I'll even say test item count simple, right? But then maybe I want to come down here and write another test for the item count for an empty order. An order with nothing in it. So it's going to be the same 3 steps. It's going to be the same 3 steps. We have to set up our objects. So this time I don't need an item. I don't need one of these menu items. I just need an order, right? So set up objects. We just need an order. We don't need a menu item this time. Call method being tested. That is actually the same method as last time. And then we're going to use our assertions to verify the results, the big difference being that, okay, now I expect that number to be 0. So I kind of flipped the order on this a little bit. In practice, I would have tried to conceive of as many tests for this method as possible before writing the code. I just did one. And then I wrote the code because I wanted to kind of show you how that process works. But in practice, I'm going to sit here and try to write, I've decided I want to test get number of items. Let me think of all the possible ways that I can test such a method. There are other ways that we could think of testing this method, such as do we want to allow the ability to remove items from the list? Because then, okay, now I actually have more things to test. Can it properly detect when items are removed and keep track of them? So those are all things that would need to be tested in order for me to consider that method to be quote-unquote thoroughly tested. Trying to think. All right. Let's do something a little bit more complicated. I want to write tests for computing the total of the order, right? How much the whole entire order is worth. That's more complicated code. That's going to require at least a loop to go through the list and retrieve the prices and add them all up, right? It's more than just saying how big the size of the list is. So and it's also important. People want to make sure that their order is going to be totaled up correctly. They don't want to get overcharged. Probably won't complain if they're undercharged, but we care about that. So it's important to make sure that this stuff works, and it's going to be the same process. Let's think about all of the different ways that we could test a method that is going to compute the total of this order. It's kind of the same sort of issues that I would conceive of for number of items. If I have an empty order, will it properly tell me that the balance of the order is $0? I would hope so. I hope that's possible. If I add an item to the list, can I see that it's just the price of that one item? If I add 5 items to the list, is it going to properly sum up those totals? Let's write all of those tests right now, and then we'll write a method and see if we can get it to pass the test. So the 3 tests that I just said are, test total empty order. Test total one item. Test total many items. It's also important, I actually forget this all the time. For whatever reason, very, very often forget to put that test annotation in there. They will not work properly if you don't do that. Forgot to do it up here even. So I've now thought of 3 different things that I can test, 3 different situations that I can test for computing the total, right? And actually, I would argue that this is maybe even sort of like the bare minimum. I would argue for you to consider even more situations. Is it possible? You have kind of the same ideas of if it's possible to add the same thing more than once. Is it possible to remove items? Then we have to recompute the total. All these kinds of things. But these are good enough for us to work with for now. And we're going to follow, again, the same 3-step process. We're going to set up our objects. We'll call the method under test. And then use assertions. So for the first one, it's just an empty order. We know how to set up an empty order. Oops, that did not paste very well. Okay. In fact, we can kind of borrow some of the structure of this past one. Here is our empty order. Step 2, this is where we have to make some design decisions because this method doesn't exist yet. So it needs to tell us the total. We need to decide what we're going to call that method. We need to decide if that method has any input parameters. We need to decide if that method has any return values. So we're calling a method that is going to compute the total of the items and tell us what that is. So I think that there definitely will be, a return value. I'm not so sure I'm convinced that there need to be any parameters for that though, right? It's just based on whatever the list contains, whatever the order contains. And in this case, we need to assert a little bit differently, and it has to do with the data type. Integers are an exact data type, so we can always compare them exactly. But people learn pretty quick that doubles are fuzzy, right? They don't always give you the exact value. They have rounding errors. That's the reason why. It's the short version of why that is the case. But what that means for us is that anytime you're comparing doubles, you have to give it a little bit of wiggle room. You can't just say that it has to be exact, pi you can't say exactly a value when it comes to a double. You have to give it some tolerance. You have to give it some wiggle room. And so I believe assert equals will let us do this. Yeah, here we go. Let's import the assert equals method. It's going to take 3 values. The first value, I believe, is going to be what we expect the answer to be, which is 0. The second value will be what it actually is. That's the result that we get from our method call. And then the third value is called delta. What we're saying is that we're going to allow the answers to be off by 0.01 and still consider that to be okay. It's a tolerance. Anytime you're comparing doubles, there's a possibility that there will be some error involved. So you have to provide some tolerance. You have to provide some wiggle. It's necessary to do. All right. Let's proceed with these other tests. So I'm going to go ahead and borrow my French fries code from up here for the one item. I'm going to call the method being tested again. And the assertion this time won't be expecting 0. It'll be expecting 250. So I'll say that. All right, one more to go. This time I want to add more than one item, so I'm going to grab this code for the French fries. And I'm going to make some other stuff too. So burger and a soda. And, keep the number, for unit tests especially, right? Keep the numbers somewhat simple so that you can actually verify what they're going to be. I might change these a little bit. Burger is probably going to be like $8 or something. I don't know. Soda's like $1.50, $1.75. Okay, doesn't really matter. Should probably change these as well. Also need to make sure they get added. So the setup for this one took a lot more work than it did for some of the other ones, right? That's not unexpected. If we're going to test methods thoroughly, that means testing them when there's not much stuff going on, and also testing them when there's a lot of stuff going on. We'll be able to work in all of those situations. We want to make sure they work in as many situations as possible. All right, we'll call the method being tested again one final time. Oops. And then write an assertion. We have to do a little bit of math here for this assertion. It's 250 plus 8, so that's 1050, 11, 1225. Should be 1225. And we've written 3 more unit tests. We're now going to go and write the code to make these tests pass, which is actually, I would argue, sort of the least interesting part of today, perhaps. So I'm going to try and go through it relatively quickly because I want to focus more on the actual unit tests. What did I call it? I called it compute total. I'm just going to use a for each loop to go through the list because I like for each loops. I'm going to need a variable for my sum. This is actually a classic pattern called the accumulator pattern. Sum plus equals get price. There we go. I believe that should do it. So a little bit more work here, right? A little bit more work. The hope is that once I run this code, it should pass the unit test. So let's come back over to our unit tests and run them. And if I expand the list, I see here's all the tests that I've written, and they all have green check marks, right? So it worked. It worked. Again, I know this is kind of backwards to how people approach unit tests. In fact, even on the project, I know that many of you are going to ignore this idea, perhaps not intentionally, just because it feels easier, right, to write the unit test first and then go write the code second. I'm actually going to ask you, on the next homework assignment, I'm going to ask you to write unit tests, just unit tests, and no actual code to pass the test. Like, don't even care about the code to pass the tests. Just want to see the unit tests by themselves. It's going to be tricky. Not tricky from a coding perspective, but just tricky from like a mindset perspective, thinking about the problem perspective. It's a very different way of approaching these kinds of things. A lot of people want to just dive in and start writing code. It's important to be able to demonstrate that the code works. So that's kind of the whole idea behind test-driven development. Let's write the test first, say how we want things to behave, and then make the code verify that in fact works properly. The last thing that one of the last things that I want to show you, depends on how much time we have. A lot of you perhaps noticed that there's a lot of duplication. I was copying and pasting a fair bit of today. Step 1 in particular requires a fair amount of duplication of creating the objects that are necessary. And if any of you felt a little bit wrong of copy pasting that chunk of code over and over again, I actually did. I felt a little bit wrong doing it because it's not necessary. It'd be better if we could recognize that repeated code can be abstracted out. It's a very powerful concept. It works a little bit differently with unit tests, however, because we need to be very careful about how we approach our unit tests and how the unit tests are run. I don't. Let me think about how to say this carefully. The outcome of a test should be independent of all of the other tests. Meaning that if I have 10 tests, this test should still pass as long as the code didn't change, right? If I run the tests in a different order, it shouldn't affect whether the test passed or So that can be a little bit tricky, this idea that tests should not interfere with one another. I'm really trying to start from the same baseline every time, set up the testing conditions, run the test, verify the results. So having like interference or overlap between the tests can make things difficult, which means that for unit tests, we really want to have a clean slate every time. A clean setup, a clean baseline starting point every time, which means we reinitialize the objects at the beginning of every test, just to make sure they're brand new, they're fresh, they haven't been used in a prior test, or something like that. Okay, so in order to remove this redundant code while still respecting that idea that we're going to have a baseline for every test, we're going to use a different kind of method in our unit tests, one that I like to use quite a bit. I'm going to add a different annotation here. Is it let's see, is it before? Yep. It's called @before. And then I'll usually call this method setup or something along those lines. So by adding this method and using the @before annotation, that is telling the unit test that it is going to run this method before every unit test. Every single one. So if there's any code that you want to run at the beginning of every single unit test, you can put it here. Put it in this method instead of having to put it at the beginning of every single unit test. So that's going to help us go back and kind of clean things up a little bit. What that means is instead of creating all of these things over and over and over again, I can take this and create them up top. So I'm going to take all of these. Anywhere I'm calling the constructor, I'm going to remove that from the tests, and then let the setup method do it instead. So only the things that we're calling the constructor, the order, the menu items that I had, and then any of those lines that we're calling the constructor within the unit test, I've taken them out. But only the ones that we're calling the constructor. Notice that if I had other lines as part of the setup, I left those in. You'll notice that it can't see them anymore because we've removed those. But we know how to fix that. We can create some instance variables. So it's possible to have instance variables in unit tests. In fact, very useful. Actually, here you go. This is a better way to do it. Fries, burger, soda. There. And then in the setup method, we want to make sure that we're not creating new versions of these, but storing them in the instance variables so we can make sure that text looks blue to match. And now all the errors are gone on my screen. If I went a little bit fast and lost you, I apologize about that. Let me know if you definitely ask if you need any help or if you got lost along the way. But notice that all of the unit tests down here on my screen are not complaining anymore. I can actually rerun the unit tests if I want to and verify that they still, whoops, they don't pass. What did I do wrong? I screwed something up. Hang on a second. I think... there we go. I wondered. It's, so @before just runs it, I guess, once at the very beginning. I think what we want is before each. My bad. Thanks, Google. Yeah, so when I had it as just before, this was only running once at the very beginning. That's not what I wanted. I wanted it to run once at the beginning of every unit test. So hopefully this will fix that. Let's see. There we go. Although I do have one problem with something. This one failed. What happened? Oh, I think I got a little overzealous when I was deleting stuff, because you can see here it says the test is supposed to be testing one total item, and I deleted the line that added in the French fries. Which is honestly, I think, a good thing to actually take a moment and point out. Unit tests are code written by humans. Any code written by humans is bound to have mistakes. That is just a fact. So I make mistakes. Everybody makes mistakes. Unit tests can have mistakes in them, just like any other code can. Have to be careful. There we go. Yeah, fixed my little error. All right, let me go back to what I was talking about. So by using instance variables here, you can see how much it cleans up the setup phase in particular. I can just add the items directly to the objects instead of having to create them, call it the constructor in every single unit test. And for some of the tests, after extracting that out, you can see the setup phase is basically empty now. It's all taken care of by the setup method. So I don't even need to do anything in the actual test. I can skip step 1, go straight to step 2. That's okay. That's totally fine. The setup method is taking care of the setup phase for us, so we don't necessarily have to worry about it here, right? Any questions so far? Any questions? Okay. We've got about 20 minutes left. So I do have a couple of other things that are on my agenda for today. I want to repeat something that I kind of talked about at the beginning of class, which is that not every method needs to have a unit test. So what methods should we be writing tests for? Not constructors, typically. I have not written any unit tests for constructors today, nor would I. Getters and setters, typically no. So we actually did have some getters and setters. You could even argue that the ones that I wrote for, get number of items are perhaps a bit too trivial. I think it's a good way for us to learn how to write unit tests, though. Anything that does any sort of computation absolutely needs as many unit tests as you can possibly think of. So as soon as you start doing any kind of math, anything at all that's more complicated than just returning a value or setting a value, gotta have unit tests. And I'll be looking for this on the project as well. I'll be looking for what's called test coverage, right? If I see a class that has 10 methods in it, maybe 8 of those are getters and setters, but the other 2 better have a heck of a lot of tests. I'm going to be looking for that specifically. There should not be any methods that are not tested in a project, ideally, unless they are constructors, getters, and setters. We don't test those. The other thing I want to talk to you about, I promised we would do some command line stuff today. So I want to show you how, I want to give you this code, actually. I know some of you have been following along, which is great. But I want to put this code in a repository and give it to you. And this is something that's going to be important for you as well, coming up with the project, because you're going to make a project and you need to put it in a repository. So let's talk about that real quick. And we can also maybe talk about how you can interact with your Eclipse projects via the command line as well. So I'm going to switch over to the command line. And if I run ls, I can show you that in my home directory there's folders called Eclipse Workspace, and I think the workspace that I was on was actually called SP23. So if I go into SP23, yep, oops. So the Eclipse Workspace, whatever workspace you tell Eclipse to use at the beginning when you first start it up, that's just a folder that it creates. And inside of that folder are all of your Eclipse projects. So the Eclipse project that I created today is right here. The exception to that is if the Eclipse project that you created is from a Git repository, those go in a separate folder called Git. So here's all the ones that are from, Git repositories. But back to the task at hand. If we take a look at the project that was just created today, inside of that project directory, I see two folders, source and bin, where bin is short for binary. That is where the computer stuff goes, right? The source folder, that's where our stuff is. But actually, let's take a look at the bin folder real quick since it's here. If I do ls, all right, let's. Those are our packages. Those are the packages that we created. When I said that packages are just folders, they're just directories, I mean, that's what they look like on the command line. They look like directories. If I cd into the menu, you'll see, whoops, I didn't mean to do that, sorry. You'll see that eventually I see class files. Class files are here. We talked about this last time. Class files are the files that the computer needs to run your code. Okay? Who made these class files? Eclipse did, but it did it using the javac command on our behalf. Whenever you click that green triangle in Eclipse, it's running javac. It's making the class files and then running the Java command, running the Java program with the class files. The code's all here too. So if I go into the source folder, there's our two packages again, menu and test. If I go into the menu directory, I can see there's our two classes. Right? There's the code that I wrote. So it's all here. It's all on your computer. It's all accessible. Okay. The other things that are here, if you do an ls dash, whoops, sorry about that. I ran the wrong command. Is it ls dash a is what I want? Yeah, here we go. ls dash a. We see some, remember, anything that starts with a dot, that is what's called a hidden file. That basically means they don't want you to mess with these. They're usually created by programs, so they don't want people to mess with them because the computer's creating them, maintaining them. But these two are actually important for us to know about. If we want to take our Eclipse project and add it to a repository, these two files contain the project. So in order to take this project and put it into a GitHub repository that can be shared with people, we need this file, and the source one. We don't need this one. Definitely do not want this folder. Remember, we don't ever commit class files. Keep those out of the repository. Just want the source code, the .class path file, and the .project file. And if you want to know more about what they are, you can actually open them up and look at them. There's nothing wrong with that. Just don't tweak them too much. If you don't know what you're doing. This one just says where Java lives, basically. So where does Java live, which version of Java we're using. And then the other one just says that this is the name of the project. And that's really about it, honestly. It's got some other stuff about Java in here, right? But Eclipse looks for these files to know that there is an Eclipse project. So if we wanted to make a repository for these, well, we first need to go to github.com and make it. I already have menu system, so I'll call it menu system 24. Not worried about any of that other stuff for now, just creating a repository, so I've got one. I'm going to clone this empty repository and then copy those files into it, like I was telling you about. So git clone that brand new empty repository. I'm going to copy the .project file into there. So this command says copy the file that's in this directory called .project into this directory. I'm going to run another one for .classpath. And then we need to do one more for the source folder. And this is a common error message that I get asked about, actually. Let's see if we can decipher what it's saying. Copy command. -R not specified, omitting directory. So -R, if you aren't familiar with what that is, it's actually a very common flag that is used with many commands, but copy is one of the more common ones. You can also just look at the man page for copy and see what the heck it's talking about. -R should be down here. Recursive. So what that means is it's going to copy not just the folder, but all of the files in the folder. So if you want to copy a folder and all of the contents within that folder, the -R flag is required. And that is what we were trying to do here. The solution, I mean, that was a lot of words to say. Just put the -R on it. I'm going to CD into my repository and take a peek. Ah, wrong flag. There we go. Whoa. It's the second time that's happened. All right. So here I've got .classpath, I've got .project, and the source directory. I'm now ready to add those files. And you can add them one at a time if you want to, but you can also use a shortcut, git add star. Star is a wildcard operator, it means add everything. Add all of them. So git add star, git commit, project setup, git push. And there it goes. And now hopefully if we go back here, we'll see that we have the git project on here. Oh, whoa, did it not add the .project file? Hang on a second. Oh, it didn't. So star did not pick up those files, I guess presumably because they're hidden. That's annoying, actually. I'll add them myself then. Okay. Hopefully that worked this time. Okay, good. Yeah, there they are. Yep. So now what that means is that if I post a link to this repository on Canvas, which I will, actually will, you can grab this code and load it up into Eclipse and poke around. If you weren't able to follow along today, you can take a look at this. We're going to go through this process too for many, many, many more times. Basically, any chance I can see to write some unit tests, I'm going to take it because I believe it's such an important skill to practice. But I had one final topic before I let you go because I got 10 minutes left. I wanted to talk about running code via the command line again because it's possible to actually run code that I've written in Eclipse via the command line as well. We know how to do that. First, though, I have to add something to this code. We don't have a main method. Is that a little weird that we've been doing this all this time without a main method? Not necessarily. We've been writing unit tests and running unit tests. We don't have a main method. We don't have a method that says do something, right? Which I'm just going to go ahead and stick one in now. And honestly, while I could make this main method do all sorts of things, I'm just going to make it say hello because I'm more interested in just the practice of compiling and running this code via the command line than anything else. Let me save this. Make sure everything is saved. All right, everything's been saved. I'm in the repository, so I'm going to switch back over to the Eclipse project. All right, if I take a look, there's the main method, right? There's the main method that I just wrote. So I wish to compile this code. Oh, but wait, I've got 2 files, right? It's not just 1 file, it's 2 files. So if I do that, you can see that it's going to get upset at me. It says, I don't know what a menu item is. So there's 2 ways that you can fix that. Whoops, I forgot the C. Of course, you can just type the other Java file out here. That's going to get kind of tedious, especially as your projects grow. You continue to have more and more files, right? It'll work. Notice that when I compile this way, it just dumps the class files right here. That's probably not where I want them. So it's considered bad form, actually, to keep the class files here. If you remember, there was actually a bin directory that it was putting them in. There is a way to make that happen. I guess we'd have to take a look at the man file, because I'm not sure I even remember what it is off the top of my head, where it dumps those files. I'm not going to look at it right now. I want to continue on with running it. The main method was in the order class. So again, remember, when we run it, we don't type .java, we don't type .class. We just type the name of the class that contains the main method that we wish to run. However, I think we're going to run into a little issue here. It tells me wrong name. What the heck? That doesn't seem right. It looks like it's correct to me. It's called order. The difference between the files that we were doing yesterday and the files that we're doing today is the package. So here's where the package matters. In order to run this Java program, the package has to be included as part of the name of the program. So the proper command to run is java menu.order, where menu is the package that the order class is in. And you can see, oh, it's still upset at me. It still doesn't like that happened. Why not? Well, a package is still a directory. So what this command is actually saying is go look in the menu package for the program that is called order. That is where it's going to be found. But I'm already in the menu. That's where I am right now. So it's looking for a package called menu here in the directory where I currently am. That's not correct. We need to cd up a level, and then finally we can say java menu.order, and that works. That was a lot more complicated than the way that I showed it to you before, right? It's a bit trickier. But it's a more accurate representation of how this stuff is going to be working in real life. Java programs are meant to be run from the source folder. So actually, even when I'm compiling it, it might be worthwhile to compile it from here. You can compile it by saying something like this. Go into the source folder, locate all of the files that end in Java, in .java, and compile those files. Oops. Well, where do I get a file not found error? How did that happen? I'm confused by that. Oh well. I am in the source directory. That's how that happened. I should have said menu. Yep. Thank you. Should be menu, not source. All right, yeah. Right? So instead of going all the way into the menu directory and then compiling the files, and then leaving the menu directory to run more standard approach would be compile it from the source directory, run it from the source directory. Always, 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 always. And then just always remember to use the package up front when you run the program. This is again going to be tricky. It's going to take some practice. It's something I'm going to ask you to do on the project, so you'll get practice at it. Yeah. Any questions? Covered a lot of ground today. A lot of information to sink in. So that's all I got for you for now. Let me know how the homework assignment's going, okay? I will be around all weekend, grading exams mostly, but also answering your questions. So if you get stuck on assignment 3, shoot me an email. Be happy to chat with you about whatever problems you've got. I know it's a tricky one. Have a good rest of your week, okay?
Thank you.
What's up?
I was getting first dog.
Oh, did you say anything on the desk?
Yeah.
What's that? Oh dear, that I'm really not.
For what?
I need to pick up these. I left some pamphlets at the gifts to me today, so I have my 133 exams. And I don't have a Hey girl, how are you? I'm great. And I have some for my life there. Oh, right. Yeah.
I was nervous. When I started, it was just such a mixed class. Wow. So cool.
I wonder that every time. No, I had literally tried one thing. And it was like the garlic boba, and then I feel like
It's a set of problems, but I don't know what kind of I'm stumped, man. I honestly do not know. I don't think it's anything that you did there. I think it's just there's something wrong with the settings, but it is concerning. Like I don't understand why his job is stalled, so it's fine. Have you restarted Eclipse at all? How your other classes going?
Pretty good, pretty good. First,
Midterm season yet?
not yet. That kicks off next week.
Next week, okay.
Like finance and CS.
Okay.
We got 332.
Oh yeah. Still the same. This class is actually pretty big.
Yeah, it is. So have that extra credit was like all main core stuff.
Like we should like release a report here like parallel course.
No way.
Apparently that was it.
Thank you.